Good afternoon. Welcome to today's webinar, New Requirements for Fall Protection. In January of 2013, the American National Standards Institute and the American Society of Safety Engineers released ANSI ASSE A10.32-2013 Personal Fall Protection Used in Construction and Demolition Operations, one of a series of safety standards that has been formulated by the Accredited Standards Committee on Safety in Construction and Demolition Operations. During today's program, the presenter, served as the chair of the Standard Committee, will provide an overview of the new standard, definition of terms used in the standard, planning requirements, equipment requirements, system requirements, training requirements, employer requirements, and finally, manufacturer and testing requirements. The presenter for today's program is Daniel Paine. Daniel is a construction, safety, and fall protection expert. He's a certified safety executive and a professional member of the American Society of Safety Engineers, past general chairman of the Construction Division of the National Safety Council, and a member of the Board of Directors of the Veterans of Safety. Mr. Paine is a frequent lecturer on the topic of worksite safety and fall protection. He co-authored the book entitled Elevated Work Platform and Scaffolding Job Site Safety Manual, which was published by McGraw-Hill in 2004. He has authored and produced articles and films addressing elevated worksite safety issues. Mr. Paine has been found qualified to testify as an expert witness in numerous court proceedings, and he has given expert testimony on the subject of work site safety and fall protection. He's also testified as an expert for OSHA at the public hearing for the adoption of 29 CFR Section 1926, Subpart R, steel erection. We will take 2 question and answer breaks during today's program. If you have a question for a presenter, please feel free to submit it at any time by using the chat or Q&A feature located on the right-hand side of your screen. We'll do your best to answer the questions in the order in which they are submitted. Tomorrow morning, I will send out an email with a link to the archived recording of this program, as well as a copy of the PowerPoint presentation. We do ask that you take time to fill out the survey that will appear on your screen after today's program is over. I now invite you to sit back, relax, and enjoy. I'm going to turn the presentation over to our distinguished guest, Mr. Dan Paine. Dan, the presentation is now all yours.
Hello, everyone. This is Dan Paine, and together you and I are going to explore the new procedures and protocols that need to be followed for fall protection. And believe me, they are new. So I think one of the first things we'll do is to talk about and give you some standards that are important, some other standards that are important that reflect on this particular standard you're going to hear about today. The first one would be under the American National Standards Institute, ANSI ASSE, which is the American Society of Safety Engineers, and those standards that deal with construction are ANSI A10 standards, and there are 50 of them. I'm going to pick out 3 of them that are of importance in this particular situation. The first one would be A10.1, which is pre-planning for construction safety and health. And pre-planning is going to be one of the key things that we're going to talk about in here as a protocol. The second one would be A10.26, which is emergency procedures for construction, which will talk about how you rescue someone when they fall. And the third one would be A10.33, safety program requirements, which talks about all the program requirements for safety in construction. Now, in addition to those standards, there is the fall protection standards under the ANSI ASSE Z.359 or -359.1, and that's the standard that references how you manufacture and how you test the equipment that we're going to talk about in this particular standard. In addition to that, there are a bunch of other standards under the Z359 Fall Protection Code, which also are available through ASSE. In addition to this, the National Safety Council has a Accident Prevention Manual, 12th edition, which has two particular books that are important. One is Administration and Programs, and the other is Engineering and Technology. These two books outline most of what's in here, plus what's in the ANSI A10.33. So the point being that the consensus standards that are out there are covered in a number of different standards that are available. Finally, OSHA itself has a compliance directive, which you can find online under OSHA.gov, and it is called CPL 2-0.124, and that particular standard is good because it talks about the different kinds of employers on a construction site, including the creating employer, the exposing employer, the correcting employer, and the controlling employer. And we're going to talk about all of those as we go through this presentation. These will be also sent to you as part of the documentation that you're going to get from Matt Hyde tomorrow. In addition, there is one other thing that I would like to point out. I have talked with ASSE, the American Society of Safety Engineers, and they have agreed that any of you, if you want to buy this A10.32 standard, that we will give you a discount from $77 to $57, and you can get that by calling 847-699-2929 with a market code of 131032. Again, this will be sent to you by Matt Hyde. Okay, let's get started. Background. And I think this is important that I give you first a quick history of the standard. This standard has been around for quite a while under different names. First, it started out as being called the ANSI A10.14 standard, and that was back before OSHA, back when the first use of safety belts and lanyards were used. And that standard covered some of the rudimentary things that were done, and it came up with some of the requirements that were there, such as a 6-foot lanyard, which, believe it or not, was as far as you could see in a mine with a light on. That's where 6 feet came from. It was nothing particularly engineering or engineered. And secondly, the 5,000-pound requirement was calculated. Now, in addition to those, it went from that to the A10.32, and the A10.32 standards that existed prior to this one included primarily how you manufactured and tested the equipment, with a few items in there about how you would use it and how you would train people. And this has all changed because the workplace environment has all changed. And really, that's what this is going to be about today. This new standard is really about procedures and protocols and training and rescue that is required today. Okay, why we need to have a process to determine what hazards exist and how to eliminate and mitigate them. Most accidents occur because we do not determine what the hazards are, and we do not know how to eliminate them, and we do not know how to mitigate them. We have just used solutions to problems with very little knowledge, and that has caused a lot of accidents. We're also going to discuss why there is a need for selection and use and training of fall protection. There is a need to know what piece of equipment you're going to select and use, okay, that makes sense for the application that's there, and what the sequence of those selection techniques will be. For instance, you eliminate first. If you can't eliminate, then you try to passively mitigate it by using, and we'll talk about what those passive methods are, and then as a final solution, you will use active fall protection, where you actually have, in a fall arrest situation, someone falling, and then you have to capture them. Now, the problem with that is that has its own risks that go into there, depending upon the physical condition of the person who's going to fall, because lots of things can happen, and we're going to talk about that as well. Now, the final thing, question that I want to ask as far as background goes, is why we need to know the limitations of the equipment and how to rescue. Because obviously, the limitations are going to be how far are you going to fall, what are you going to potentially impact, and how are you going to rescue a person after he's fallen if it's going to be a fall arrest situation. Let's go to the next slide. This standard applies to the following categories. To the users of the fall protection equipment. That's anybody who's going to use fall protection equipment needs to know all about it. To the persons responsible for the selection, procurement, inspection, use, care, and maintenance of the equipment. Those are people who are normally selected by the general contractor, and he selects them through the use of one of the qualified persons, which we're going to talk about, and then the competent person, who's generally the superintendent or foreman, who is the person who is going to make sure that the inspection and use are in accordance with the manufacturer's instructions and the law. And to those responsible for training and supervision of the users, because training is a very specific thing today, and the individual who's going to use the equipment needs to know everything about the hazard and everything about how to use the equipment and what its limitations are. Now, general requirements. Each employer on the work site shall be responsible for analyzing the project to detect fall hazards to employees, shall eliminate the hazards. Now, you try to eliminate every hazard you can. You can change the work sequence, or you can do anything on that site that would eliminate the hazard. Obviously, that's the best thing, because if you don't have a hazard, then you don't need to do anything more about it. Now, if you can't change the erection and demolition sequence, and you can't put in any engineering controls or provide protection against falls to employees, then you need to use either passive or active fall protection. And who are these requirements for? Well, they're for the general contractor, the subcontractor, the creating contractor, one who creates the hazard, the exposing contractor, those people who are exposed to the hazard, the correcting contractor, those who can correct what takes place, and the controlling contractor, who in effect is the general contractor and or the owner, depending upon which state you're in. Let's go into some important definitions, and I bring these up because they're very different than the definitions that were out there in the past. And I want to make sure we're all on the same page when we talk about what they are. Let's talk first about active fall protection. That requires the exposed person to wear or do something to prevent potential fall. First of all, with active fall protection, doesn't matter what kind it is, you have to wear a harness. And you have to know how to don that equipment, which means to put it on and put it on in a proper method so that it works as it's supposed to work. You need to know how to install that equipment. In other words, you need to know how to hook in the connector to the anchor point, and you need to know how to do that, and you need to know what its limitations are. And you need to know how to use that equipment. Because if you're going to walk from point A to point B along a platform, as an example, you can imagine that potentially the distance you can fall before you hit something is going to change. Now, passive fall protection, which is your first line of defense rather than active, and this is the reason why, it does not require the wearing of it or use of any fall protection equipment. It's equipment where you have guardrails or platforms or safety nets, which are installed for the use of the individual, and he doesn't need to know, the individual who potentially is going to fall doesn't need to know anything about them. They're there and they protect it. People who install them obviously need to be trained. Now, a new item that's in here that was not in other standards prior to this is the Anchorage Connector. Now, an Anchorage Connector is a very important thing because everyone probably knows what an anchorage is, and in the case of fall arrest equipment, you have to have an anchor point which has a 5,000-pound strength requirement. And that's so that the whole system, which all has 5,000-pound strength requirements, will fit together and there'll be no weak link. Now, that's the anchor point. That anchor point may be a piece of steel, maybe a piece of concrete, maybe a piece of wood, maybe lots of different things. That's the first key thing. But the second key thing is what kind of connector are you going to use to get to that anchorage point? And there are multitudes of different kinds of connectors that can be used. And as some examples, let's take a look at the following. Here are some anchorage connectors that I've picked up for you to take a look at. If you want to take a look at what we have here from the point of view of, if I can get the right item here, I'll be all right. These two right here are ones that are used in steel, and what you do is you put those connectors through a hole in the steel, and then you have a 5,000-pound connector, assuming that the steel is 5,000 pounds. Secondly, you have this type of connector, which is a movable connector, which you can attach to the top of an I-beam, and it will move along that I-beam with you so that you have mobility in addition to that. This is another type of connector down here, which can bolt into concrete, wood, or whatever else. And another good way to do it is this particular set of circumstances, which shows you that when you wear a harness and a lanyard, that you can throw around a beam a strap which has a big D-ring and a small D-ring. And the small D-ring goes through the big D-ring, and that gives you a connector which develops the full force of the piece of steel. Now, that was steel. Let's take a look at the next area, which would be the next major area, which would be concrete. If you're doing a new building and you want to have an anchor strap in concrete, what you do is you have a slab which you're pouring, and you take that concrete slab and you take a lanyard, which you can see right here, and you put it over the rebar, and you pour the concrete. And then that will develop the full strength of that concrete, which should give you a 5,000-pound anchor point. And therefore, you can place these where you need them, either in the wall or in the floor, depending upon where you're working. And this looks like this once they're completed. So what you can do then is you have a safety strap that's here, which hangs down, which you can hook into, and this allows you to move on the outside of this guardrail system, which you can see right here. And what that does is it gives you fall protection anywhere you are in the building, whether it be here or above or wherever you want to pour them. And then what you can do when you finish is you can take a knife and cut them off right here, and they go away. Okay, let's continue with our important definitions, which are here. Some more important definitions are clearance requirements, which includes the total fall distance. Now, that's the distance below an authorized person, who is really the person who is going to use the equipment, that must remain clear of obstructions, something below it, in order to ensure that that authorized person does not make contact with any objects that would cause injury in the event of a fall. Now, sometimes people don't always think very clearly, and that's why I want to just show you a couple of slides here, which I think will bring it home. Here's a guy with a horizontal lifeline system on. You can see it right here. And he's walking across the bridge. And what he doesn't want to do is to hit the ground below. However, there can be obstructions such as this truck. And you can see what happens if, in fact, he falls and that truck is coming through. You need to know what's going to happen before it happens. That's why you do a survey of the job. That's why you need to know the limitations of the fall protection that you're going to use. Obviously, up here, there should have been a guardrail system, and the guy should have been working on the other side of it, or there could have been a safety net system, or there could have been some other means and methods used that wouldn't allow him to end up here. All right. Now, one of the things that you're going to find as you go through this is that all the different manufacturers will tell you what the total fall distance is of their equipment. And they have charts such as this. And this is one that I'm using so that you'll get an idea of what we're talking about. This is how we protect people from getting hurt. Here you see someone standing on a floor or a beam before a fall, and he's hooked off above his head. Now, he's going to fall from where his feet are. He's going to be tied off above his head. So that what you have is a straight line fall. And in a straight line fall, this is what happens. You have the 6-foot length of the lanyard. You have the 3.5-foot deacceleration distance, which is here for the shock absorber, which is in the lanyard. And then in this particular case, we've chosen the worker to be 6 foot in height. Whatever he is, you add that into the equation. And then you have a safety factor of 3 foot. Now, why do we have that? Because you're going to potentially have a stretch or elongation in both the safety strap or lanyard and the deacceleration device or shock absorber, and certainly, additionally, the full body harness is going to stretch. So that is why you have the safety factor in here. Now that gives you 18.5 feet. Now, let me give you an example of why I'm showing this. Because most buildings that you're in are going to have 15 feet between floors. So if you use that piece of equipment in an area that has a fall distance of 15 feet, guess what? You're going to hit the floor. So that isn't the way you're going to go about it. There are many other kinds of devices that can be used, and you need to know that. Those of you out there who are lawyers, which I assume are most of you, you need to know this because this becomes one of the criteria that people are going to judge whether you had proper equipment or not. Okay, a few more important definitions. A competent person. That name is thrown around quite a bit. And but let me tell you who he really is, and I think it's very important. He's an individual designated by the employer to be responsible for the immediate supervision, implementation, and monitoring of the employer's managed fall protection program, who through training and knowledge, I'm talking about the competent person, is capable of identifying, evaluating, and addressing existing and potential fall hazards. Now, the key thing on the competent person versus the qualified person, who we're going to talk about in a minute, is who has the employer's authority to take prompt corrective action with regard to such hazards. He's not only somebody who's competent in what's taking place, but he has the authority to stop the work if that's what it needs. Okay, fall protection. Fall protection is any equipment, device, or system that prevents an accidental fall from an elevation or that mitigates the effect of such a fall. Now, fall protection includes eliminating or controlling hazards. And passive fall protection, restraint, fall protection, and administrative controls are the ways that you normally would go. Keep in mind that fall arrest is the last solution because it's the most dangerous. A qualified person. We talked about this a little bit under competent person. But a qualified person is a person with a recognized degree or professional certificate and with extensive knowledge and training and experience in fall protection and rescue field who is capable of designing, analyzing, evaluating, and specifying fall protection and rescue systems. Now, that's very important as to what he is. He is the expert, so to speak, the qualified person in putting together your system. You need to know who he is. There's also a qualified personal trainer, and that's a qualified person which we just talked about before, who is also qualified to provide fall protection training. Another very important qualified person is a registered professional engineer, and that engineer needs to be registered in the state in which the work is taking place. And he needs to have expertise in the discipline applicable to the scope of the work. There are lots of professional engineers out there, and a lot of them aren't qualified to do this kind of work. And their license is at stake if they don't do it and do it properly. So you need to make sure you got the right person. Planning. Now we're going to go into the guts of what we're talking about here. And I think planning comes down to be one of the key things. And whether you call it planning or pre-planning, I don't care. But prior to the start of the work on the project or the phase, each employer, now remember we talked about all kinds of employers before, including general contractors, subcontractors, etc. But each employer shall conduct a survey of the job site, review the drawings, and conduct discussions as applicable with one or more of the following. They need to talk to the owner. They need to talk to the engineer. They need to talk to the general contractor and or the construction manager to define, eliminate fall hazards, and do whatever is necessary to ensure the fact they have a safe job site. Now, the plan itself needs to be a written plan, and the plan shall give preference to elimination of fall hazards. And the first thing you'll use will be, if you can't eliminate them, is passive fall protection systems, such as scaffolds, guardrails, secure covers on the floors, and barricades on wall openings, and aerial lifts as opposed to fall arrest. Keep in mind, we're not asking the individual to have to do anything to protect himself. What we're doing is providing him a working surface platform with protection to make sure that he can do his job safely. Now, at each location that a fall hazard cannot be eliminated, and a worker is asked to rely on an active system. We're talking about fall arrest, we're talking about anything where someone has the potential for falling and there's no other way to take care of it other than to have some kind of fall arrest system, a written JSA, which is a job safety analysis, will explain why it cannot be eliminated and how it will be mitigated. Now, this is also covered in one of the standards we talked about before, ANSI A10.33. And what I'm going to do is to show you next how one of those job hazard analysis plans can be put together. This comes right out of A10.33, and what you do is you list the activity, and you can list them down here. It can be you got to walk from point A to point B, and that includes the unsafe conditions that you have different heights as you walk along this particular area, and they need to be protected from falling. You can't do it with anything other than an active fall protection system. Then you need to point that out and why. And then how you're going to prevent or correct that action. It's that simple. But that needs to be done for every specific hazard on the task and job that you're going to perform. And that needs to be part of your records, because that's the kind of records you as attorneys who are out there should be looking for. And they should and need to exist, and standards require them. Now, the site-specific fall protection plan, that's what we've been talking about. The area or task for which passive protection cannot be provided. Say, we can't provide any passive protection here, and then we need to give a reason why such protection cannot be provided. And then the name of the person who shall prepare the job safety analysis is required by Section 3.2 of this standard. Now, it's also required under A10.33, and it's required in a number of the other standards that I gave you at the beginning of this presentation. And what the retention responsibilities for the JSA are. Those retention responsibilities are normally that they be available at the site and that they be kept for a period of time after the project is completed. Obviously, you can require them if you want to, when you're doing discovery, that they not be thrown out. At the start of a construction project and for critical stages of work, a written fall protection, prevention, hazard analysis shall be conducted and a site-specific fall prevention plan prepared and included in the project site-specific safety plan. That's what we've been talking about. There it is. This plan shall describe the potential hazards and actions required in order to eliminate or control each identified hazard. Now let's go to equipment selection, because that becomes very important. If the hazard cannot be eliminated or controlled passively, then appropriate fall arrest equipment must be selected to restrict the individual or arrest a fall should it occur. Now, keep in mind that active fall protection equipment goes into three categories. One, fall restraint. In other words, you tether them so they can't get to the area where the fall would take place. Secondly, you can have someone who gets in place, and we're going to show you this, where they need to work and they need both hands free. What you can do is there are systems available for positioning equipment. So you can position someone in a place where he can work and it restricts him from falling any great distance. And thirdly, of course, there's fall arrest equipment, which will result, and usually does result, in at least a 6-foot fall. And that's the maximum free fall, but that isn't the maximum total distance you're going to arrive at. Now, I just pointed out what the 3 areas are here, and all active systems require a harness, a connector, and an anchorage. Now let me explain what we mean there. A harness is what it says, a full body harness with a D-ring at the shoulder level and in the back. In addition to that, you need a connector. And the connector can be a lanyard, it can be a self-retracting lifeline, it can be connected into a rope grabbing device or other devices. But it is the connection between the harness and the anchorage, an anchorage connector. So, to the extent possible, a personal fall arrest system, when stopping a fall, shall be rigged such that an employee can neither free fall more than 6 feet nor contact any lower level or obstruction. We've talked about that. Fall arrest. The minimum required clearance for the fall arrest system shall be determined by a competent or qualified person, usually from the charts provided by the manufacturer. Adequate clearance shall be available through the path of the worker's movement. In other words, if you have changing distances, whatever you're going to use must take into consideration the worst situation, not the best. I'm just showing you these calculations to show you there are other calculations. We talked about this one. This is one using a self-retracting lifeline or retractable lifeline, and you can see the distance is different. And there are different distances for different means and methods that are used. That should be available through the equipment manufacturers who manufacture them, so you know what you're getting. Training. Let's talk about training for a minute. The employer should provide a training program for each employee who might be exposed to a fall hazard, and the program shall enable each employee to recognize the site-specific hazards of falling, and shall train each employee in the procedures to be followed in order to minimize these hazards. Relative federal, state, and regulatory requirements, procedures, and standards shall also be incorporated in the JSA. Now, before we go on, I think this is the point, and I think it was a slide before, but this is the point we want to take any questions.
Yeah, Dan, we do have one question that I'd like to get to, and then we can continue on with the presentation of content. JC has a question about anchoring. He asks, how would one anchor in a residential wood shingle roof, and how best to do that for 5,000 pounds?
Okay. When you get into especially roofing, if you go to any one of the equipment manufacturers that are out there, they will give you different means and methods that you can use for anchorage. One of them is to use an eye-bolt system at either end of the house with a horizontal lifeline across it. Other systems are ones that can be nailed in, and they are designed with a nail pattern goes to provide that 5,000-pound anchorage that you need. And others are set up. There's a thing called the whirly bird, which is pretty much a retractable lifeline that is anchored into the roof through a nail pattern again, where you can hook into it, and it gives you a lot of mobility, so that as you move across the roof, you are totally protected. And it takes into consideration such things as the swing or pendulum effect, and also these self-retracting lifelines, if you're using them, also have a length of the cable that's protected. So if you do go over the edge of the roof, you're not going to fall to the ground now, but go over the edge of the roof, that it won't be cut by the edge of the roof. I hope that answers your question.
Okay, great. I don't see any other questions in the queue, so why don't we continue on with the presentation, Dan?
All right. So we started on training. Let me go a little further with training on this. It's the employer's responsibility to train. The employer shall assure that each employee has been trained as necessary by a competent or qualified person in the following areas. Now, there's a number of them, and they're on a couple of slides, but let's start off. The nature of the fall hazards in the work area. In other words, what kind of a fall hazard is there? You're going to fall off a roof? You're going to fall off a deck? You're going to walk off the end of a scaffold? What is the nature of the fall hazard? How far are you going to go? And what do you need to do about it? The correct procedures for erecting, maintaining, disassembling, and inspecting the fall protection system to be used, whether it be an active system or a passive system such as a scaffold, or it be an aerial lift, or whatever it is, you need to know what the proper procedures are for using that equipment. Some of these pieces of equipment, such as an aerial lift, require certified training. The use and operation of personal fall arrest systems, safety net systems, and other systems to be used all need to have somebody who's trained to either erect them, put them in place, or use them. Now, also, employees shall demonstrate an understanding on at least the following. And you need to make sure that your employees know these things. Otherwise, they are a potential cause of an accident. How the individual components function together as a system to restrain or arrest their fall. They need to know how that works. They need to know how to properly don and adjust their harness. Now, you don't just put one on. You got to make sure it's tight. You got to make sure that all the connections are made, and you got to make sure that it fits you. You don't have one that isn't of your proper size. Then you need to know the proper tie-off procedures, inspection and maintenance procedures. And what I mean by that is you need to know where you're going to tie off. You need to know that you need a double locking snap hook. You need to know that you don't want to be able to roll it out. You need to be able to inspect your harness and or lanyard. You need to know that such things as acids can deteriorate that nylon so that it doesn't work and it will kill you. And you need to know what maintenance needs to take place to make sure that it's clear of all kinds of potential hazards such as concrete that's stuck to it or paint or whatever doesn't affect its workability and reliability. And then you need to know rescue procedures. You need to learn how the equipment is to be used on any specific project, what the unique hazards are, and if you fall, what's going to happen to you? Can you self-rescue yourself, or are you going to need a rescue, and what to expect? If you hang up there, for instance, a piece of fall protection equipment, an extended period of time, the straps in the legs and the rest can cut off the circulation in your body. And when you're released, all that blood can rush to your heart and kill you. So you need to have an adequate, quick means of rescue. Employee training must include lectures, demonstrations, and hands-on experience in performing tasks. That does not mean that you can just sit around and go to a toolbox talk. That's not what we're talking about. We're talking about the training needs to be site-specific. You don't care whether somebody knows about every kind of training. For instance, elevator shaft training in a building that has no elevator shafts. The lectures and demonstrations and hand-on experience need to be about the things that you are going to do. And the training must include determination of the total fall distance in order to establish safe working heights in accordance with the manufacturer's programmed instructional materials. And all manufacturers in the United States, at least, have programmed instructional material. Let's talk about rescue for a minute, because rescue becomes a key thing. You need to have training in rescue. This was never really had a lot of attention paid to it in the past, and it's one thing to be saved by a fall in fall protection equipment, and it's another thing to die because you weren't rescued properly. So let's take a look at this. Here's one type of rescue equipment that can be used. What you have is you have a controlled descent device. So what happens is that once you fall and are arrested by this, then you have a device over here which can lower you to the ground. This is a great kind of device that people who are working on the side of a building where they're using a bosun's chair can use to get themselves down as they're working on the outside of the building. This is just one system. There are many systems. And they give you charts again telling you what you need to know. Okay, here's a perfect example of how are you going to rescue these people if they fall. They're way the heck up in the air, as you can see. They need to have a pre-planned rescue program. This is not a wild suggestion of where someone might be. This happens every day, especially in steel erection. Site-specific rescue plans. Just like you have to have a site-specific plan for fall protection, now you need to have a site-specific rescue plan. And that shall be developed and included as a part of the site-specific fall protection, which will provide for prompt, efficient, and safe rescue for employees. Now keep in mind, these systems and these plans in a lawsuit help both sides. You have a plan, you've done your job, you've done everything you can do, you can show how you tried to protect your employees and what you did to do it and what you provided. On the other hand, if you don't have one, okay, then the plaintiff's side of the case is going to take a look at what took place and say, well, they didn't do any of these things, and industry standards and OSHA says you need to do them now. So, if you're going to have someone fall, you need to do the same thing you do with the rest of the plan. Because if you don't know where someone can fall, you don't know how you're going to rescue them. Now, rescuers need specific training. Now, that means all rescuers, and by the way, there's a category of people now on a site who are provided to be first responders or rescuers on almost every construction site I know of. I should say every good construction site I know of. All the major players have them. Okay? And they have adequate training and equipment and personal protective equipment where needed. Some rescuers and first responders can come from outside sources, such as EMTs, police, fire, or hospitals. And in a lot of smaller jobs, that's where they do come from. Because of the fact, you know, if you have someone fall, whether it be a residential situation or it be a small construction situation, it's going to be the EMT guy that comes on out there, police, fire, or hospitals. Now, one thing people haven't been very good about making sure that happens is the outside sources need to be part of the plan and be advised in advance of what problems to expect. They need to know what the MSD sheets say, you know, the material substance that's on that site, if there is any that is hazardous. They need to know where the entrances are, because entrances on construction sites normally change. Roads normally change. The construction or demolition normally changes. And what kinds of falls and potential fall protection equipment is being used, and what should they expect to find when they get there? If they know this in advance, think about it. They can respond much more effectively and quickly. Now the handling of rescue equipment. I think this is important because when equipment is solely designed for rescue, it's available, it needs to be identified as such. You don't want it used for any other purpose. And it needs to be kept in a separate location from the daily use of fall arrest systems, meeting the ANSI ASSE A10.32 and or the ANSI ASSE Z359 requirements. And you need to see the ASSE A10.26 Emergency Procedures for construction sites when you're going to take a look at what kinds of things are required. Now, the requirements for the manufacture and testing of active fall protection systems. All active fall protection equipment and systems must be made and tested in accordance with ANSI ASSE Z359.1-1997. That's also available through the American Society of Safety Engineers. Equipment that isn't specified in that standard, and there is equipment that's used that way, then it must be tested and approved by a professional engineer, because we need to know that the equipment that's going to be used meets the standards that are out there, even though no specific manufacturer either makes it or it doesn't fit in the situation where you want to use it. All active systems are listed in ANSI A10.32-2013 Standard. We list the standards. We don't tell you how to make them. And we don't tell manufacturers how to make them, and we don't tell them how to test them. That comes under Z359. But we tell you what they are. We tell you what you can get, and they include such things as harnesses, lanyards, including self-retracting lanyards, and Anchorage Connectors. We talk about vertical lifelines, including rope grab systems, and horizontal lifelines. And horizontal lifelines are a very site-specific subject, because of the fact the length of the lifeline, how it's supported, how many support systems are in there, how far they're going to fall, how many people are on the system. Those are all questions that need to be answered, and they are things that are available from a manufacturer and or by that registered professional engineer we've just talked about. Now remember, if the hazard cannot be eliminated or controlled passively, I'm going to re-emphasize that. If the hazard cannot be eliminated, and a lot of hazards can be eliminated, all you need to do is change the erection sequence, change the sequence of how you're going to demolish the building, change the way you go about building the building. If you can't do that, then you need to look next to passive systems such as scaffolds and guardrails and lifts, because those are much less difficult to learn to use. As a matter of fact, there's very little learning experience on the people using them, only on the people erecting them. And then, if you can't do that, then you should use the fall arrest equipment in the standard. And it must be selected to restrict the individual or arrest of fall should it occur. And the whole idea behind this is, let's not have a fall any further than it needs to be. Now, let me just give you some pictures here as we close out on some of the things that can be done. This is what you would call right here, I don't know if you can see that, but I hope you can, an adjustable lanyard. So what he can do is he can adjust the length of that lanyard depending upon how far it is from where he is to the ground. Obviously, he's at this level right now. Next time he may be at that level up there, or he may be at the level below him. So he needs to make sure that whatever he has, if he should fall off the edge, he isn't going to hit any obstructions. The next area that we're going to take a look at here, and I'm trying to find my own place, is the harness and the lanyards. This just shows it where you have a harness and a lanyard that's tied in, and a shock absorber probably, and that is a 6-foot type of fall, and it's fixed. Now, we talked about rope grabs. That is a rope grab. It slides up and down the rope. You can fix it in place by putting it in there and locking it by pulling the handle down. And as you climb, it will follow you up the rope. And the lanyard normally is less than 3 feet. And the rope can move in either direction. And you need to make sure that you keep that rope, though, within 5 degrees of where you're going to be working, because if you go more than that, you have a pendulum effect situation. But you need to have that determined by the person who is going to be in control of that site. It's a great piece of equipment where it can be used and where it makes sense. Now, these are self-retracting lifelines, and this just shows you what they are, SRLs. And when someone falls, that device as he falls, locks, usually within 2 feet maximum, depending upon how they're set up. And then he just falls the length of this lanyard that he has pulled out, plus an additional 2 feet. And that's where he's going to end up. So where it's attached, how far it is before he meets an obstruction become a very important consideration. I told you I would show you using positioning, and this is a positioning system where someone has a rebar hook tied into his D-rings on the side of his belt, and he can put his feet down here below, and he can work with both hands free. Quickly now, because we're running out of time, safety monitors are another way of warning a worker of fall dangers, and where the job is going to take a very short period of time, and it doesn't make sense maybe to have fall arrest equipment, and you can't have any other kind of equipment. You have somebody physically standing behind a warning line to tell someone they're getting close to the edge so they don't fall. And then finally, I think what I want to show you here is first the pictures show how critically important fall protection equipment is. This is an actual fall where a guy fell. Now, it wasn't one guy, unfortunately. Second, they show how far flexible wire ropes deflect. They deflect. And using the height of a fallen worker as a scale, the total deflection of the wire rope calculates to 34 feet. The workers were very lucky when they were working 88 feet above the ground. If their work platform was 25 feet above the ground, they would have hit the ground and hit it hard. That is the end of the presentation. I hope it was good, and I will take any questions if there are any.
Okay, we're right up against the 3 o'clock hour here, so why don't we wrap up the presentation, and if you have any questions for Dan, we will, you feel free to email them. You can send me an email or reply to the email that you'll get from me at 3:30 Eastern Time today, and I'll forward those on to Dan. Dan, is that okay with you?
That's fine with me. I'll be happy to answer any questions for anyone, and I hope everyone enjoyed the presentation.
Yeah, if you'd like to speak to Dan about a specific matter that you're working on right now, you can contact us here at TASA. Our telephone number is 800-523-2319. As we indicated during the introductions, tomorrow morning I'll send out an email that will include a link to the archived recording of this program. In that email, I'll include a list of the standards that Dan mentioned, as well as a way to order the new 10.32 2013 standard from ASSE. I will also include in that email a copy of the PowerPoint presentation. Our next webinar for legal professionals, Student Safety Door-to-Door Part 2, will take place next Tuesday, February 26th at 2 p.m. Eastern Time. You should have received an email from me inviting you to that presentation today. If you don't have it, you can send me an email and I'll get that to you. If you have any follow-up questions or comments, please feel free at any time to email me at mhyde@tasanet.com. We take everyone's comments under consideration, and they help us to present better programs. On behalf of Dan Paine and all of us here at TASA, I want to thank you for spending an hour with us today, and we hope to see you at future TASA events. Thank you, everybody.
Okay.